Hi everyone, my name is Oyelami Temitope Ibidunni. I'm from Nigeria. I'm a 5th semester student of digital engineering, and I'll be the one to anchor today's interview. With me here today is one of our professors at the Faculty of Computer Science. Could you please introduce yourself?
Yeah, thank you for this introduction. So my name is still Mossakowski. I'm a professor for theoretical computer science here in Magdeburg, and my specialization area is modeling in various kinds, so logical modeling and formal modeling, as well as modeling with ontologies, which are certain shared conceptualizations, and also modeling with the unified modeling language, which is subject of this course.
Oh, okay. So this interview will be about modeling with UML, with semantics as a course. And the information provided today will be for international DE and DK students that will be interested in taking this course. Could you give us a brief course overview?
Sure. So the course is about UML, so I should say a few words what UML is. Okay. So it's the unified modeling language, which is about modeling software systems and also to a lesser degree hardware systems. So that's quite important, because before you start to write code, you actually capture what are the requirements of your customers, what is the overall design of your software system, what are the components, what's the behavior of your objects, what the interaction between the objects, and things like that. And with this conceptual thinking, you can avoid many costly design errors that later on lead to very costly. For example, there was Airbus designing things in France and in Germany, and then they didn't fit together, and it cost them billions because the design was wrong. And with UML, you can check the design beforehand and only later come to writing code. And UML is about designing at various levels. In the course we will cover use case diagrams. So that's basically what's the use of the software for your customers. Class diagrams, so that's what is the data that you use in your software systems, what kinds of objects are there. You have state machines, so what's the behavior of objects. Then you have sequence diagrams, what is the interaction between different objects. And you have also activity diagrams, what are typical workflows within a system. So all these kinds of diagrams will be covered in depth, as well as their semantics. So the mathematical underpinning, what's, for example, in a sequence diagram, the semantics would be a trace of events, and then you can mathematically precisely capture which traces are in the semantics of a given sequence diagrams and which traces are not. And with this you can also verify your design, and also verify your design against some implementation in code.
Yeah, it seems so interesting, and it's like it's applicable in many areas.
Yeah, sure.
Yes. Okay, so after taking this course, like you've mentioned that about the Airbus that was made earlier, what other application areas, I mean, what other job prospects do we have?
Yeah, so there are many companies in various fields, like, I said, Airbus or energy domain, automotive, that use UML for modeling, or similar languages like SysML. And so there is a need of computer scientists that understand UML. So I think it's a quite good prospect. If you complete this course, then you increase your chances to get a good job in industry. So.
That's interesting. For a student that successfully completes this course, is it possible to take a team project, interdisciplinary team project? The 12 credits D project, maybe?
These 12 credit projects are for DE. I think they're too hardware specific for for me as a
okay.
more software and theory oriented guy, but these 6 credit projects are possible.
Okay,
Yeah.
okay.
And we have some cooperation with Fraunhofer IFF in the energy domain,
Okay.
and so we have also kind of an application area.
Okay. Do you have any master's thesis that you have supervised before or you are supervising presently or could be possible for any student that have taken this course before?
Yeah, I have supervised 2 master's theses on UML and applications together with Fraunhofer IFF actually.
Oh.
And I think there will be a 3rd one. I'm not entirely sure. So yeah, usually after this course there are some students doing a master's thesis.
Okay, that's great. So for students coming from maybe computer science background or maybe from another background, especially these students from chemical engineering, electrical engineering, what are the prerequisites for this course? Yes.
That's an interesting question. So you need a basic understanding of software. So you should be able to program in some object-oriented language like C++ or Java, because UML is an object-oriented language as well, although not for programming but for modeling. But the object orientation is the same, so you have classes, subclasses, inheritance, and so on, and you should know these notions already.
Okay.
And you should also have some mathematical background, like sets and functions. What is this? So one student answered to my question, what is a function? Yeah, it's a button on my computer. That's not the answer I would like to have there. In this context, a function is a map that maps values from an input domain to values in an output domain. And so, yeah.
Oh, okay. So it's, how about the strategy of getting good grades for this course?
Yeah.
I know it's good to have understanding of the course, but at the end of the day, you would like to have good grades. What are the strategies of getting good grades?
Yeah. So one important aspect is that you should not just learn by heart, but you should try to creatively think of an application area. For example, a common exercise is about modeling some traffic light. And then you should understand the application area and creatively transfer this to a UML model. So you should, of course, master UML, but also have this transference capability. And you get this only by practicing. So you should actually come to the exercises. We have actually a tutor which offers exercise sessions, and you should do your homework and present your solutions there and discuss with the tutor. You get valuable feedback, and if you make a mistake there, it doesn't matter so much. The important thing is that you learn. So understanding the course and participating in the exercises and homeworks is very important. Yes.
Okay, thank you. Then so over the years, students have been taking this exam. So what are the exam of this course? What are the typical mistakes that are commonly made by students?
Yeah, one very common mistake is just learning by heart. And some students even learn complex formulas on the slides by heart that even I don't know by heart. You should try to understand the underlying concepts and methods and practice them. Understanding
is a very key concept.
Exactly.
So on a general note now, we would like you to advise students that have determined or decided to take this course, or some that are still not very sure and they would still like to be motivated. So could you motivate students that would like to take this course or are still contemplating whether to take this course or not?
Yeah, so if you like to learn an industrially relevant language and like the challenge of transferring knowledge from a domain to a computer science oriented formalism, if you also like to to play around with the mathematical meaning of that, then you're right in this course.
Okay, so thank you very much, Professor Theo, for being here today. We really appreciate we appreciate the time and the information you provided us with, and thank you very much. And maybe on the screen, your information will be there. I mean, the opening hours, and even students would like to contact you for theses or projects. Maybe they can contact you through email. Yeah. So thank you very much for your time.
You're welcome, and thank you for making this interview possible.
Thank you.